Hey, Clint Mason here, president at Kaizen Well Solutions. I'm down here in West Texas watching some of our staff put on a well tracer application. Basically, the well tracer is where we inject CO2 with gas lift gas, and we're able to monitor the returns, and we can tell you all sorts of information about what's happening downhole. We can tell you which valves are operating, how much they're open, if you got holes in the tubing. There's a lot of advantages that the well tracer service provides to our operating companies and customers. And I'm just sitting in one of the trailers. This is one of our older units, but what we have here is that's the analyzer unit. And as you can see, we're just getting a baseline, and I've probably got this on the front, so it's probably backwards. But anyways, that's our baseline information that's coming across here as we're getting ready to inject some CO2. This unit here is actually set up so we can do 2 wells at one time. Anyways, I'm gonna wander around and show you the wellhead and the tie-in facilities as we're going along here. So we're standing outside the trailer here, just looking in, and we look inside the trailer. You can see what we got going on there. Probably hard to hear me over the gen set. Anyways, take a little tour of the wellhead facility and how we have things tied in. So right here is our gas injection side. This particular cable or line is our CO2 injection line, our pressure transducer, our gauges, and we're just going to inject CO2, our slug that's going to go into this line and then enter into the casing over here. On the production side, we're coming out of the tubing. You can see running along this large line and carrying along, and then here's our sensing line, transducer and line, and off this line we take a very tiny amount of gas sample that runs back to our trailer, and when we get back to the trailer we analyze it and watch the CO2 returns, and that can tell us when we're starting to see our CO2 slug. You know, one of the very first things that we do is we come onto location and we tie in to the casing, and we use our echo meter to get fluid levels to make sure we know where the fluid level is on the back side or on the casing side of the annular side of the well. So here inside the trailer we have a CO2 bottle with liquid CO2 that actually has a dip tube that goes down into the liquid, and we have a nitrogen bottle. The function is that we're going to take this CO2 and we're going to push it out to the wellhead, and we're going to use, because CO2 has a lower pressure, we're actually going to use the nitrogen to force that liquid CO2 down into the well if our pressure in the well bowl was higher than what the CO2 tank operates at. All of this is controlled, and you can see we have a transducer monitoring the pressures, and we're getting ready. So shortly we're going to do CO2 slug injection. So we're injecting liquid CO2 currently, and we're going to basically we take a weight, and our goal is typically to inject about 25 pounds of liquid CO2, and we watch that, and we just do it with weight on the bottles. Once we've achieved that, we'll stop the CO2 injection, and then we'll start monitoring what we're currently monitoring inside as well, watching for CO2 returns in case you had a leak right at surface or something that could come in right away. So we start the test before we inject the CO2 to get our baseline, usually about 15 minutes of baseline, and then we'll inject the CO2. Now the CO2 is injecting, and we'll be able to start the monitoring test. So here we are on the injection side again, and we're getting ready. All the lines are open. We can see our lines are open now, and we're ready to inject our CO2. Our field tech is getting everything ready. We've taken our weights so we know exactly how much CO2 we're going to inject, and typically we inject about 25 pounds in one of these wells, a wells facility like this. So now that we've injected that CO2 slug, and it's going down this line and down the casing, we're waiting for that slug, which stays in a pill almost as it travels down that casing, and as it crosses any kind of opening, whether it's a hole, whether it's an open valve, whatever it is, we're going to get a percentage of that CO2 slug is going to start and is going to enter into the tubing and come back up, and then where we're monitoring it back over here, that's going to allow us to see when that CO2 comes back. Now, understanding velocities in the casing and the tubing and some of the software that we use, it gives us very accurate depths of where these CO2 traces are entering the tubing. So, beautiful Texas morning, a little cloudy. So as you can see, I've started the test. The CO2 has been injected in the well. This red line is indicating our baseline CO2, and what we're looking for is basically a spike. Now, because we know the design of the well and stuff, we'll have expected times when we should see that. This test is going to take about 5 hours to get that CO2 slug from the top of the well, down the annulus, right to bottom, and then back to surface again to ensure that we've checked the entire tubing length. So as we get some information to come in, I'll add some more video. We're sitting here and we're waiting. There's some pieces and parts that we can see. Basically, this is the flow that we have going through the system. All our pressures, low pressure, high pressure, all our controls and shutoffs for the well tracer system. This is an AppSmith technology that we're the exclusive licensee for North America for, and we work with AppSmith very closely. Currently we have 4 units being set up in West Texas, and we're looking to expand into the Colorado eastern slope area around Denver, and into not only West Texas but South Texas as well. And included in this service, we also do full gas lift, plunger lift equipment design, supply, and full service. We'll wait and see if we get any kind of indication of CO2 returns yet. So far, we're not seeing anything, which is good. We're only about 26 minutes into the test, which had about a 15-minute baseline before that. So we've had CO2 traveling down that casing for about 10 minutes, or 10, 12 minutes right now. So hopefully we're not going to see any returns for a couple of hours. We expect it to be at the bottom of this well. So our predicted return time for our first return should be 3.5 hours. And we do that by getting all the well data from the customer and running it through our software, our program. And it'll give us expected return times and volumes and percentages. And if the actual returns don't match the expected, then we know that there is probably something that is not correct. It could be many things. It could be a valve is an issue. It could be plugged open. It could be washed. It could be that we even have we sometimes will actually identify that their metering is actually off quite a bit, and we have to readjust our program or our survey when we get proper test data for flows and that. So we do see that a lot. But the interesting thing is, once we have this data, we can always input new data. If we had an injection rate expected of 300,000 or 14 E3 500,000, and what we found is it was only injecting at 80% of that, then we can adjust that in our software, and it would correct that and line everything up accordingly. So anyway, we're 30 minutes into the test, and it looks like we've got about 3 hours to wait. So while all the data is being stored on the well tracer unit, we've hooked up our data port, which is going over to our computer now, and we can start monitoring and evaluating the returns. And so still we're about 30 minutes into the test, or 28 minutes into the test, and everything's looking good so far. So here's our flow rate meter. Typically we keep that below 2. That's the gas that's flowing through the analyzer, volume that's flowing through. So as this test goes along, now we've, earlier I showed you we were doing a fluid level, and we used the echometer system. We're currently just going through the data to identify where that fluid level is, and yeah, we're just working on that right now using the TAM software, which is an excellent software that we like to use a lot. So here's our fluid shot on that well, and just a second here. Let's turn this off. Here's a fluid shot on this well that Brett took, and he just built the well profile with gas lift valves, so we can see basically every kick that reflects off a gas lift mandrel, or and these are all side pocket in this well. Yeah, I believe so. I'm not sure. Anyways, as we're working through this, and then you can see we got this big kick here, which is indicating our fluid level. So we're about 7,983 feet measured depth from to fluid. So where would that put us, Brett? That should put us right at valve 12.
Between valve 12 and valve 13.
So yeah, between valve 12 and valve 13. So we're about, and what is there for total depth in this well?
16 valves, and that is 97.85.
16 valves, 97.85?
Yeah.
So we got another 2,800 feet to go to get down to the orifice on this one.
Yeah, so we won't go past that.
No, yeah. So this is indicating we can't see anything below the fluid at that 79.83. So basically that's showing us that we aren't unloaded, or the well is still pushing fluid above the orifice. So you're working through the valves. So you can see when we use, there's a couple of modes. One is you can use a marker, and the other way is to just do a collar count, which the computer program figures out. And if we look at this with collar count, we're about 78.85 or something. And if we use a marker, which means we identified a device or a reflection down hole, like a mandrel, or it could be a mandrel or a sleeve, or some sort of a marker down hole that we know the depth with, and then that'll help us fine tune the total measured depth. Anyways, this is a couple of ways we do it. So the difference between our marker and our collar count is about 100 feet difference in between. So it's pretty close considering the noise that we have in this well and stuff like that. So it's we have high confidence that our fluid level is right in that 79. So you can see when Brett's going in, those kicks and right along the edge, they line up with our valves, our valve position in our well model. So we know those are good markers, and it's given us good information on where those kicks are, where the depths are, and that gives us very good indication on where that fluid kick will be too. So that's how we identify what the actual fluid depth is. But you can definitely see those kicks and those little gray L-shaped things. That's where the indication is where the valves would be. So here's the CO2 concentration. Although it looks like it's increasing, it's really not. It's going between 0.22 to 0.26, which is pretty normal. It's very, very low CO2 concentration, so we know we're not getting any returns. But we're about 15 minutes into the test, and still monitoring, no returns. I don't know if we'd even be down to the first valve yet in this one, would we? Probably be getting close. But
first valve is 57 minutes.
57 minutes.
Yeah.
That's when we reach it, or that's when we'll get the returns?
That's when it should come back.
Okay.
From this point.
Oh, okay. So there we go. So that's where that
That's the injection of the CO2.
That's the injection of the CO2. So 57 minutes from that point, if we got a problem with valve 1, we should start seeing a spike in CO2. So we'll monitor and see what we find out. So here we are, about 2 hours, 13 minutes into the test. You can see we got a return of CO2, that big spike that you can see that's coming in here. Actually, I'll show you from our big screen here. Anyways, from our CO2 injection point to the return, it was about 1 hour, 47 minutes, 48 minutes. And in our predicted returns, we that actually indicates we're around, we should be at valve 4. I think our prediction was like 149 or something, 144 on valve 4. And it's 2 hours on valve 5, so it would indicate that we should be at valve 4, so we're getting returns there. I don't know what that means yet. Have to look at the completion and everything, and where those valves should be set. It does seem a little high for where the fluid level is, I think, but we'll find out shortly. So you can see that the spike now is starting to drop, and if you look right there, it's starting to come down. So that means that pill of CO2 that we've injected has moved past that valve, and or moved past that valve, and only let a small amount of that CO2 into the system. It is a big return, so there's a lot of gas that's going through that particular point. We believe it's valve 4, or I believe it's valve 4 from our guess, or our evaluation and estimated times for return. So we'll see once we get all the data in if that's correct. So here we are at the end of the test. Total test time was about 5.5 hours with our startup, or our getting our baseline. As it turned out, we only got a single return. That single return was at valve number 6, and that would indicate that we should have actually been down around valve 13. But that would indicate that there's a serious issue with that valve. It's washed out or broken. Something's happened to it. So our customer will have to go in with wireline and pull that valve and replace it, replace it to get that gas injection down where it should be. This is the graph. It's pretty basic. We have the one single return, and actually you can see there's a bit of a tail on it here. Typically when you see that tail, that indicates it's kind of the end where all of your CO2 is going. It might be a little more at a curve lots of times, but probably what's happened in this well, because it is so high, some of the it's all going through that one valve, so our full 25 pounds of CO2 came back in that one shot that we had injected. And yeah, there's no injection going any deeper than that. So that's the end of the CO2 tracer test on this particular well. If you'd like more information on the well tracer product or any of the Kaizen Well Solutions product, go to our website at www.kaizenws.com. That's kaizenws.com. Thanks.